You are listening to The Vocal Technologist. Spoken tech for your ears.
An AI just designed a synthetic virus from scratch, and it actually works. Let me explain.
Yeah, it's genuinely wild to think about. We're watching artificial intelligence leap from, generating text on a screen to actually manipulating the physical world in ways we really haven't seen before.
Right. So as your vocal technologist, the bit rattling around my head is just how rapidly this shift is happening. I mean, we're moving way past text boxes that write polite emails.
Far past it.
We're talking bespoke biology, silicon etched with AI brains, autonomous coding agents, and just massive terrestrial infrastructure. I want us to take a proper look at all of this. We really need to nut out how AI is bleeding into our physical reality.
That is the fundamental shift we need to untangle. What we're watching is a massive industry-wide move toward vertical integration.
Okay, vertical integration.
Right, so it's about connecting the software to the hardware and ultimately to physical control. The boundary between the digital world and the physical world is, well, it's collapsing.
Yeah, let's start with the biology part, because that's the one that really grabbed me.
Oh, absolutely.
Researchers have basically taught an AI to recognize patterns in DNA structure, right?
Yeah, exactly.
And then the AI used that data to write recipes for entirely new, non-natural viruses. They actually created these DNA molecules, shoved them into bacteria, and proved they were viable and infectious.
Which is a huge leap.
I reckon that sounds incredibly dodgy. Are we just letting an algorithm cook up pathogens?
It definitely sounds alarming at first glance. I mean, I had the same reaction. But to understand why this matters from a technological standpoint, we really have to look at the underlying mechanism.
Okay, suss it out for me.
Well, we've spent the last few years being completely amazed that an AI can predict the next word in a sentence, right? It learned the grammar of human language.
Sure, it figures out that the cat sat on the is usually followed by Matt. It's just predicting tokens.
Exactly. Well, what this new research proves is that AI can learn the grammar of biology.
The grammar of biology, because DNA is basically just code anyway, 4 letters instead of zeros and ones.
That's it. The AI is treating sequences of DNA like tokens in a language model. But instead of generating a poem, or like a Python script, it's generating a sequence of base pairs.
Right.
And here's the massive difference. A synthetic image of a cat just has to fool your eyes on a flat screen.
It just has to look right.
Exactly. But a synthetic virus, it has to satisfy the laws of biochemistry and physics. It actually has to fold into a specific three-dimensional protein and successfully interact with living cells.
Oh, wow. So it's proving that AI can reason about physical, biological realities, not just spit out words that sound clever.
Precisely. It understands physical constraints. It knows how those chemical sequences will physically behave in the real world.
Man, that is intense. And if AI is getting a grip on biology, it's also getting hard-coded into our physical devices.
It is.
I saw that OpenAI is building an AI-first computer.
Yeah.
It's this displayless, hockey puck-sized smart speaker with, like, moving parts to give it personality.
Right. The new hardware push.
And it's meant to cost over $300? I've got to be honest. A $300 displayless hockey puck sounds like an expensive paperweight.
Yeah, I get that.
It just seems a bit ordinary compared to what a smartphone can already do.
It does seem a bit counterintuitive, especially when we're so used to just, staring at glowing rectangles all day. But that form factor is actually a massive clue to where computing is heading.
How so?
Devices without screens suggest a move toward ambient computing.
Ambient computing, meaning it just sort of, lives in the room with you?
Yes, it's technology that exists in the background of your environment. You interact with it through voice, or it just takes autonomous actions on your behalf, rather than demanding your visual attention all the time.
Right, I see.
And the moving parts you mentioned, that's about building trust and signaling its state, like whether it's listening or processing, without needing a visual interface.
Okay, I can see the appeal of not staring at my phone. But for that to actually work smoothly without massive lag, the hardware itself has to change, right?
Oh, fundamentally.
Because if I talk to this hockey puck, we can't keep beaming every single voice command up to some massive data center, waiting for the model to process it and waiting for a response. The latency would ruin the illusion.
That latency is the main bottleneck. And that's exactly why the moves happening in the semiconductor industry right now are so critical. Look at AMD acquiring a startup called Thales.
Oh yeah, Thales.
What Thales does is fundamentally rethink the architecture of the chip itself.
I saw this Thales news and it sounded like absolute wizardry. They claim they're bypassing the traditional memory wall entirely. How does that actually work? Are they just building a bigger pipe between the processor and the memory?
No, not a bigger pipe. They're
Yep.
getting rid of the pipe entirely.
Wait, really?
Yeah. Think about how a standard GPU works. A huge amount of time, and energy for that matter, is wasted just moving data back and forth between the processor where the math happens and the memory where the AI model is stored.
Right.
That gap is the memory wall.
It's like a chef having to run out of the kitchen and into the pantry every single time they need a pinch of salt. You spend more time running than cooking.
That is a perfect way to visualize it. What Talalis does is bake the model weights directly into the silicon. They literally etch the neural network directly into the logic gates of the chip itself.
So a normal chip is a blank slate. It has to load the instructions every single time.
Exactly.
But with this, the physical structure of the chip is the AI model.
Yes, you aren't loading software onto generic hardware anymore. The hardware is the software.
That's wild.
And because of this, their first chip, the HC1, runs Meta's Llama model at almost 17,000 tokens a second.
17,000.
Yeah, that's 48 times faster than a standard high-end GPU running that exact same model, and it uses a fraction of the power.
17,000 tokens a second. That's absurd. So if inference gets that fast and that cheap by essentially freezing the AI into glass and metal, then AI completely disappears into the environment.
Just becomes invisible.
It's just there. You don't open an app, you don't wait for a loading bar, you just speak into the room and the ambient intelligence responds instantly.
And that ambient intelligence won't just be answering trivia questions or setting timers. It'll be executing highly complex tasks across the web, which forces us to look at how the web's infrastructure is adapting to handle these autonomous agents.
Yes, let's get into the guts of it because this completely shifts how we manage software. If AI is moving into our hardware, it's also fundamentally rewriting the infrastructure we use to get things done.
It really is.
Take Cloudflare, for example. They've open sourced something called Cloudflare OS. It's an operating system built specifically for AI productivity, featuring sandboxed apps and agent chat interfaces built right in.
The concept of an operating system for AI is a fascinating mental leap. I mean, we're so conditioned to operating systems designed for human input, right?
Yes.
Keyboards, mice,
Yeah,
touchscreen.
like standard user interfaces.
Right. Cloudflare OS flips that entirely.
Yeah.
The primary user isn't a human anymore, it's an AI agent. And that agent needs a safe, isolated environment to work within.
They even built a browser for these agents called Kitesurf. But, I mean, why does an AI need a web browser at all? Shouldn't it just talk to servers directly through APIs?
Ideally, yes.
Yeah.
In a perfect world, everything has an API, but the real web is incredibly messy.
Too right it is.
Most of the world's data is locked behind websites designed specifically for humans without neat APIs. So if you tell your AI agent to go research a competitor, it needs a way to navigate that human web.
Ah, I see.
But Kitesurf strips away all the graphics, the flashy CSS, and the formatting. It accepts the trade-off of not being pixel perfect because an AI doesn't care about pixels. It cares about structured data.
Okay, that makes sense. The technical notes mention Kitesurf runs on V8 isolates. That sounds incredibly dense. What is a V8 isolate doing in plain English?
Think of an isolate as a microscopic, walled-off room, like a highly secure sandbox. When an AI agent goes out to browse the web or run code, you don't want it accidentally downloading malware or, messing with the rest of your system.
Definitely not.
So an isolate IR creates a tiny, ephemeral computing environment. The agent goes in, does its work, and when it's done, the room is completely destroyed.
Like a hazmat suit for code.
Exactly. And it ties into another tool they released called Cloudflare Computer, which is a virtual file system.
So it's basically a fake hard drive.
Yeah, it gives the agent its own ephemeral workspace to process data securely without ever compromising your actual machine.
Man, there is just heaps to unpack here. If you're keen to keep making sense of all this with us, make sure to hit subscribe.
But letting these agents run wild at incredibly high speeds introduces a severe hidden cost.
Right.
This is a consequence we really need to examine, especially when we look at software engineering and how code is built.
You're talking about the intent debt crisis.
Exactly.
The argument that keeps popping up in the research is a really simple, almost naive question. What are code reviews even for?
It's a great question.
Right. For a long time, the obvious answer was just finding bugs before they hit production. But it's actually about how a team builds a shared understanding of a complex system.
That shared context is everything.
Yeah, and if you automate that entire review process with AI, you completely hollow out that shared understanding.
We talk heaps about technical debt in the industry. That's the known cost of taking shortcuts in your code that you'll inevitably have to fix later.
Yeah, the we'll fix it in post approach.
Right. But relying heavily on AI accelerates what we call cognitive and intent debt. These are debts that don't show up on an engineering dashboard or a sprint performance metric.
It's like hiring an automated builder to quickly add a massive extension to your house.
Yeah.
They do it in a single weekend, it looks absolutely brilliant, and you move all your furniture in.
Sounds great so far.
Sure, but when the roof inevitably leaks 6 months later, nobody knows where the pipes are hidden and nobody knows which load-bearing walls were shifted. You have the output, but you completely lack the intent and the blueprint.
That is a brilliant analogy. You own the code, but you no longer understand the code.
It's pretty scary.
By the time a critical failure happens months down the line, recovering that lost understanding, trying to reverse engineer what the AI was thinking, will be massively more expensive than if the team had written and reviewed the code manually in the first place.
And it begs another question, I reckon. If the AI is writing all the boilerplate code and the foundational systems, how does a junior developer ever learn the ropes?
They don't.
Right. If they aren't forced to suss out the basics, they never become a senior developer who actually understands the architecture.
That's exactly where the cognitive debt accumulates. The proposed fixes for this are pretty interesting, though. We're seeing platforms try to adapt to this flood of AI code.
What are they doing?
Well, GitHub has introduced stack pull requests, which essentially forces the AI to break down its giant monolithic blocks of code into chains of small, independently reviewable layers.
Okay, so making it bite-sized for humans.
Yeah. And Cloudflare has Codex, which is an AI they use to enforce engineering standards during the code review process.
But do those fixes actually work? I mean, reading an AI's perfectly formatted code isn't the same as struggling through writing it yourself. Reading the summary of a book isn't the same as writing the book.
I'd argue it doesn't solve the underlying issue. Cloudflare Codex can enforce your formatting standards and catch deviations, sure, but it's still replacing human intuition.
Yeah, the human element is gone.
It's replacing the organic, messy process of a team debating a technical design over a whiteboard. It's essentially applying an automated bandage to an automated problem.
I reckon we're trading deep comprehension for sheer speed, which, if we pan out, seems to be the central theme of where this entire industry is heading.
Without a doubt.
Because to run this new agentic web, to build these physical chips, to write biological code, you need unfathomable amounts of infrastructure.
Unfathomable is the right word.
But renting out compute power is only half the battle. If you actually want to own the physical reality of AI, you need the land and the raw electricity to run it, which explains the massive board reshuffles and physical land grabs happening at the very top.
We're entering the endgame of vertical integration. The companies that dominate the next decade won't necessarily be the ones with the smartest single conversational model.
No.
No, they'll be the ones who own the entire stack, from the raw power generation to the silicon to models, right down to the consumer applications.
Look at the talent reshuffle over at Google. Jeff Dean, their chief scientist, leaves after 27 years to start Discovery Loop.
Taking top researchers with him.
Yeah, taking top researchers to build AI that improves itself without human intervention. Then Demis Hassabis steps down as DeepMind CEO to become the chairman and Alphabet chief scientist. And while people panic about talent bleeding out, you look at the financials, and Google Cloud grew 82%.
That cloud growth figure is the absolute signal through the static.
It's massive.
There's a pervasive narrative that Google might be slightly behind in releasing the bleeding-edge models compared to some of the more nimble startups. But in the end game of vertical integration, that slight delay might not matter at all. The boundaries between these companies are dissolving.
How so? Like, what does that actually look like?
Well, agent labs are starting to train their own foundational models. And model labs are building their own consumer applications to bypass the ecosystem entirely.
Right.
So Google can afford to lose some top-tier researchers if they are the ones renting out the massive, unavoidable computing power required by absolutely everyone else.
And if we're talking about owning the physical layer, we have to talk about SpaceX. The sheer scale of their physical expansion is just staggering.
It's hard to even wrap your head around.
They're building a terafab in Texas. The initial phase alone is $16.8 billion, aiming for 100 million square feet of factory space.
100 million square feet.
Yeah, and it's designed to combine logic, memory, and packaging all under one roof.
The stated goal of producing over a terawatt of compute is a number that's genuinely difficult to contextualize.
I can't even picture it.
To put that in perspective, a terawatt is roughly the total electricity generation capacity of the entire United States.
Are you serious?
Yes, it represents an industrial footprint that rivals major nation-states. They aren't just building data centers anymore. They are building the monolithic factories that build the custom components for the data centers.
And it doesn't stop there. They're acquiring 130,000 acres of marshland in Louisiana, Pecan Island,
Right?
presumably for the massive water and cooling requirements or just sheer isolation for energy generation. They're also launching V3 Starlink satellites specifically to compete directly with mobile phone carriers like AT&T, Verizon, and T-Mobile.
Who have essentially locked SpaceX out of their terrestrial networks.
Exactly. I mean, they are launching rockets, catching starships midair, building massive chip fabs, buying up swamps, and trying to become a global mobile carrier all at once. Are they having a lend? It sounds completely absurd.
It sounds absurd until you look at the strategy, which is the ultimate expression of vertical infrastructure. AT&T and Verizon own the terrestrial towers and the fiber in the ground.
Yeah.
SpaceX's response to being locked out is to build orbital towers and the ground infrastructure to bypass them entirely.
That's quite the workaround.
Think about the synergy here. When you connect a massive AI compute facility in Texas, powered by your own energy, with a global satellite internet constellation, you are creating an independent, closed-loop network.
So they don't have to rely on anyone else's cables, towers, or power grids.
Exactly. It's a completely self-sustaining network for global intelligence.
So if we tie this whole thing together, the battle really isn't about the software anymore. From the AI that generates entirely new viruses, to the towelless chips etching logic directly into silicon, to the terawatt factories going up in Texas, the real war is over the physical world.
It is. The digital and physical realms are no longer separate, distinct domains. We spent the last few decades building software that lived in a very defined, constrained box on our desks or in our pockets. Now, we're etching that intelligence directly into the physical silicon of our environment.
Right into the walls.
Exactly. We're using it to write the biological code of living organisms. And we're constructing unprecedented terawatt-scale infrastructure to power and distribute it all. Intelligence is shifting from a tool we use to an ambient physical utility.
We're building an incredible, highly automated world. The only catch is, with all this intent debt stacking up, we might be the last generation to actually understand how any of it works under the floorboards. Think about that next time an agent writes your code. Vocal Technologists, see you soon.
Spoken Tech for your ears.